Hi everybody, welcome to this Kernel Working Group lightning talk. So during this session we will go through we'll cover all the topic on which the team is working or has worked or is going to work during the next cycle. So when I say all the topic, some topic related to some lead project like Stratos or Trusted Substrate will not be included in this. I will defer to this other project to give details. So we'll go through to a number of topic, and most of our engineers are there, so they can provide some explanation in detail in each topic. Following, so we only have 25 minutes for this session, and we have something like 10 slides, so we'll probably not have time to answer a lot of questions. Nevertheless, after this session, we have an open office hour. So we'll move to this, we'll switch to this room, and then we can continue and either go in more detail for a topic in particular and answer all the questions that you have. So let me start with the first slide there. So here are the topics. So we'll speak about thermal, cluster idling, which is a scheduler, SCMI server, the remote proc, an RP message activity, some storage area, also the 4 gig split for the ARM32-bit on which we're working, the SVA, the core site, and we'll finish with some ARM SOC maintenance, having in mind that there was a session about that just before. So let's start with the first one, which is the thermal. So it's up to you, Daniel.
Yeah. So the first point is the new notification mechanism, which is what was implemented in the thermal framework with the netlinks. So I think I already mentioned that last time, but as it's important and it's an important feature, and where the goal is to continue to evolve with the versioning. I just wanted to remind that we have this framework. So it's because it's netlinks, we can have full benefit of the network stack and with the socket in particular, and use the main loops to get events. Something we cannot have with today with the something we are not able to have with the SysFS API we had before. So it's not only notification, but it's also getting discovery of the configuration of the thermal framework, like the thermal zones and the cooling devices. So you get notified when you have new thermal zones or new cooling devices set or removed. Also, you have a set of commands. So it's a flexible tool to access the thermal framework. The second point is the thermal framework has some history. And this history was designed before for a specific platform and for a specific framework, which was a CPI. And then this framework tried to evolve to something generic. But because of this conversion between the specific to generic, it brought some code from the ACPI, which results in something a bit strange inside the thermal framework and inefficient, especially from a log point of view. And so as an important thing in the thermal maintenance is to remove some dead code and remove bogus code. So we identify every over-engineered part and remove that. And for every dead code, we remove that also, but also we identify that we have some code which was not which was bogus, and it was never fixed since years. So we assume that nobody is using it and remove it. So that simplifies the thermal framework, and it allows to set the scene for the next features we will have after. And then the third point is the most important one is in a new framework based on we call dynamic thermal power management. And the idea behind that is to fulfill what is missing with the thermal framework, which is not able to manage different thermal zones and different cooling devices. So we can delegate that to user space, or we can create an algorithm to aggregate all of them to sustain the power as a whole for all these devices. So it's a bit, I don't have enough time to explain in details that. So there is a blog where you have the link and you can refer to. And yeah, basically that's it. So we let Ulf, I think it's working on who is working on the cluster aliasing.
Yes, so a couple of words around this project that's been running for quite a while now. So it's been a close collaboration with Qualcomm, and I would say that the basic support landed in the kernel for about a year ago in the 5.6 kernel, and since then the collaboration with Qualcomm has continued, and we have evolved support for cluster idling. Basically, it's three subsystems that's involved. It's the CPU idle and generic power domain and runtime PM. So together those are the subsystems that we've been working on. Going forward, this work will continue, but we are probably moving into a little bit of optimizations rather than actual basic functionality. So during the last cycle, we actually kicked off a new project together with STMicro that recently also joined us working on this cluster idling. So in the trusted firmware side of things, the implementation of the PCI that currently lacks the so-called OS-initiated mode, support for the OS-initiated mode, which is required for the platform to benefit from the things that we've been implementing on the kernel side. So together with STMicro, that is a project that we are now currently running, and that project will continue over the next cycle. So these are the main things that we have been working on, and it's just moving forward in the next phase, I would say. Yeah, that's it. And back to you, Vincent, about the scheduler.
Thank you. Yeah, so on the scheduler side, we have three main items on which we have started to work and will continue for the next cycle. So the first one is the deadline scheduler, and we are going to do an evaluation of the deadline scheduler, and especially with the Android audio use case. And the goal is to evaluate the audio latency with the current implementation, which is mainly based on the RT task, and what would it mean to move on the deadline scheduler. So that's something that has been already been done a few years ago, but in the meantime, a lot of features have been merged. So after this first step, where we'll do a status, we will see what is the main feature that is lacking, and we'll start to work on this. So that's the first item. The other one, it's about enabling some scheduler feature on the ARM server. So few features have been enabled, but mainly on a mobile SOC system. So now we have enabled the frequency invariance, for example, for the CPPC CPU frag driver, which was not the case before. So now some ARM server which don't have AMU yet can still have some frequency invariance, just like Intel platform. And we'll continue with the thermal management, and especially would like to connect the ARM server on the thermal pressure, so that we can see if there are some nodes which are overheating. And then more specifically on the CFS scheduler. So we'll continue to work on the task, on improving the task placement on NUMA system. We haven't done all the things that we would like during the previous cycle, but we'll try to continue and move forward on this. And the last item, it's the latency sensitive task. That's also something that have been raised several times on the mailing list, and we know that some members are interested in. So we'll start to be involved on this activity and help moving forward on this, which include, for example, this nice latency discussion. So these are the three main items, and we can continue on that during the open office. So that's all for the scheduler. Let me move to the SCMI server. So for this, we have two items. The first one is that we are finalizing the upstream of the first step, in which we have a SCMI backend or SCMI server, which is running as a trusted application. So we are working on adding an abstraction layers in order to ease the port of the SCP firmware that we are using into various execution environments. And we'll continue working on adding this OptiTransport layer in this SCP firmware. And one of the next steps will be to run this firmware in a guest VM with using the Virteo SCMI as the main transport layer. This will be one of the next steps for us. And I think that's all for me. So let me let me move to the next topic on which Matthew will explain a bit more.
So on the remote processor and RP message, we have seen a fair amount of new features in the last 6 months. So what will be presented here is an overview of Linaro's activity, but also what has happened in the community as a whole. So we have seen support for detaching a remote processor, so that complements the attach feature that happened late last year. So detaching will be available in the 5.3 release cycle. On the RP message name service, 2 interesting features to talk about. First, it is now a standalone module, so it is not only tied to remote proc anymore. It can be used in other scenarios, such as virtualization between a host and a guest. It is also transport independent. So once again, allowing other areas of the kernel to use the mechanism and expand it to different realms. The RP message character driver is accessible from the VirtIO backend. So that too will be available in 5.13. And lastly, support for mini core dumps. So if you have an application processor that is memory constrained and the remote processor happens to crash, that core dump can be processed in stepped as memory is available, rather than having to process the whole core dump as a whole. With regards to ongoing work, there's a lot of activity in the area of multiplexing various hardware protocols on top of RP message. I will be coming out with a patch set in the coming weeks that properly handles crash recovery when a processor has been attached to. And lately we have seen discussions, or we have started talking about how to extend the RP message protocol. So if you are interested in that area, join us on the mailing list. So this is what I had for remote processor and RP message. Ulf will be taken over with an overview of what has happened in the storage area.
Thanks, Matthew. Yes, so the storage activities within Linaro has more or less two topics. We've been working on eMMC and SD cards. And on that level, we have been focusing on improving I/O write performance, in particular for SD cards. There's a couple of new features coming in from the SD spec that's been lacking support. So that is something that we've been looking at. But we've also been looking at new types of SD cards that supports greater speed modes. And these types are ST Express and UHS-2 things. A lot of work has been completed, but there is still some parts remaining, and so we're working on completing those as soon as we can. When it comes to the other part for storage, that's the BFQ I/O scheduler. We have been working on improving this, in particular from throughput and latency point of view, and that's been in a collaboration with a couple of guys from SUSE. Most of this work has turned out into a big patch series of small step-by-step improvements. And 2/3 of that series has been made it upstream, and we have submitted the final things for this. And so it's most likely to be completed within this cycle. So that said, when it comes to storage activities, we are planning on ramping down on this field. So more or less just move into dealing with the maintenance, both from eMMC and SD subsystem and the BFQ subsystem. So that said, we will not be driving new efforts in this field, but more or less just dealing with the maintenance. That's the plan, at least. I think that's for storage, and we can move to Jean-Philippe and SVA.
Right. Yeah, I'm working on SVA, also called SVM, which is the ability to share virtual address space between CPU and devices. It requires two special features in the device and the system MMU. The first one is the ability for the device to have multiple address spaces. We've merged that last year, support for PACID in the SMU and in the IMMU core as well, along with the possibility to share process address space with the SMU. The second hardware feature is the I/O page faults, and support for this in the SMU, and a generic page fault handler will be added in the next kernel version. This should complete SVA support for the high silicon accelerators. The user API UXA has been merged last year as well. For future work, depending on the need and the SVA compatible hardware that appears, will be upstreaming support for PRI and DVM, which allows to send TLB invalidations using CPU instructions. There is a lot of work to be done on improving and optimizing the I/O page fault handler and virtualization for SVA, which requires a lot of API work and is being discussed on the list. That's all for me.
Okay, so Mike, you're the next one.
Yeah, hi. I'm going to briefly talk about CoreSite work that's happened over the past year. CoreSite system configuration management enables the programming of components such as ETM devices especially, using some of the more complex functionality not easily accessible from the perf command line or sysfs. Programming a configuration onto a system enables that complete set of programming to be accessed by a single command, either in perf or through configfs. The baseline set includes an example of programming for ETM v4 that provides a strobing function. This uses counters and sequencing on the ETM to enable and disable trace in a user-defined mark-space ratio. So this is enabled very easily on the perf command line, and then we'll be programming to whichever ETM devices are used during the perf session. So this example has already been used to collect sample trace data and generate profiles for AutoFDO. So hopefully this baseline set will be queued in the 5.13 merge window. There will be some follow-up patch sets to this, which will enable users to define their own configurations, which will be loadable as kernel modules or through configfs. And this, along with support for CTI and other CoreSite components, will allow development of configurations that can operate across the entire CoreSite system. There's been some further CoreSite work from the community at large, which includes support for tracing when the kernel's in EL2. This is introduced with the architecture version 8.2 extensions. And there's also been some work that adds support for the architecture version 8.4 self-hosted trace extensions. Finally, support for the future architecture features ETE and TRBE have been the subject of patch sets from engineers at ARM. ET and TRBA are both internal core features that are accessed through core system instructions rather than being memory mapped external components like the ETM or ETR. So briefly, ET is an extension to ETM v4 that adds trace support for newer core architecture features, and TRBE is the equivalent of an ETR, and it's a per core component that writes trace data direct to memory accessible from the core. So that's all I have there. So I think it's over to Arne now for the ARMSOC maintenance.
So yeah, that will be either Linus or Arne. I don't know if Linus has been able to join as a speaker.
I'm here.
Great.
Yeah. I can talk about it. And, Arne can correct me if I'm saying something wrong. There was a while back a long discussion thread about high mem and the page cache specifically. There's a lot of extra code in the kernel, or especially complicated code to use the high mem for page cache, because high mem, unless you know what it is, it's memory that's outside of the kernel's one-to-one mapping, or the that you will have to selectively map in when you want to use it. The only thing you can actually use it for is page cache, and for that reason, page cache contains a lot of complicated code to deal with that. And the one place where we use a lot of high mem in the ARM architecture is the ARM32 architecture. The ARM64 does not have this problem because it has such a large address space that it doesn't need to section it into one part that's mapped and one that is not, because it has a better setup for that, many more external memory lines and so on. So we need to deal with that, and the idea is to partition the virtual memory differently so that you have one set of memory mappings for kernel space and one set for user space. Right now we are sharing this, which is a performance optimization that you do in order to speed up the kernel to user space swap. And to achieve that, this two different legs of 4 gigs each, we need to go stepwise. And what I'm looking into now is to move the kernel out of the current C0 million mapping and into the vmalloc space. So we just have to, because you always have to access the kernel memory from user space, and then you have to put it in somewhere, and then you want to put in all of the vmalloc area, which is the area which where the kernel can allocate freely. So we take some of that memory, and we use that to communicate with user space. We don't want to map in two parts, otherwise we have to map the kernel, we have to map user space. So I'm working with that, and after that we have to do some other stuff to get this nice 4x4 split, which is the other stuff you see here, copy to and from user, so that this can travel across the two 4 gig memory stacks, and so on. So this is the big picture. I don't know if you have any questions. You can ask me, or you can even preferably ask Arnd, which has the even better idea about it, I suppose.
Right, I'll continue with the ARMSOC maintenance. This is work that's essentially been going on for the past 10 years, and I'm just giving an update on where we are and what the overall work looks like. So I'm co-maintaining this together with Olaf. We've been doing this for a long time now. There's a Git tree that we maintain, so anything that is specific to one of the many ARMSOCs in around 100 different SOC families from various vendors. The code goes through our tree, and from there we send a pull request to Linus Torvalds to integrate it into the mainline kernel. Most of the changes these days are in device tree files, but there are also a couple of drivers that go through our tree all the time. And there's still platform-specific code for 32-bit. For 64-bit, the code was designed from the start to only have platform-specific drivers and architecture code that is platform-independent. So there's no strict code for 64-bit platforms other than drivers. And then, of course, we have to work with all these maintainers. There's usually around 80 pull requests I get in the merge window. And then we merge those in. Sometimes we reject something. It used to be a little bit bigger than it is now. So nowadays it's typically around 800 patches per merge window. And it's roughly 50-50 split between work for 32 and 64-bit, even though there are many more machines for 32-bit. We are adding, most of the time we're adding more 64-bit machines new, but there's still, I expect that we will see 32-bit for quite a while in new SoCs, new machines. Most recently, we have actually deleted a couple of machines. So every few years, I go through and see which of the machines are likely to not have any users anymore based on what I see from users and what else I know. And we ended up deleting 6, where we got a confirmation that the previous maintainers said, no, we are sure that nobody is using the upstream code anymore. But that also means that we still have around 100 platforms that are actively being used. And I hand back to Vincent.
Thank you. So I think that we are running out of time, but we have finished the slide. So it was the last one. So I propose to people who are interested to continue on the Kernel Working Group of OpenOffice rooms. So you will find that in the Pine application and website, and then we can answer to your question if you have any. So see you in a few minutes on this in this room. Thank you, everybody, and a good day.